Hi, I'm Gary Cody. I wanted to share with you today a little bit of a tool that VEX Robotics has made available. I believe they made it available in the spring here. It's cloud-based. It's does a simulation code you can write. Let's pull that up. But what I've got here is I'm going to do a search for VEX Robotics. And it takes me right here to vexrobotics.com, their website. And if I open up their website and we go up here to support, scroll down to downloads. And what I want to do is download software here. So here on this site, you can download all the code. Matter of fact, the regular VEX software is right down here that you can load up. But the one that I'm interested in is this one right here. It's called VEX Code VR Virtual Reality, and it's cloud-based. Let me see here. Let's scroll up. I think they tell you we recommend the following minimum requirements. They got Chromebooks down here, so hopefully the Chromebooks that you have for your students. They also show iOS and Androids. So I don't know. Might be able to use them with your phones, but I'm using it here on my laptop. So if we launch this, it's cloud-based. No software to download to your machine. And when it comes up and opens up, it's in this the block mode of programming. And this is what, if you're getting students in high school, some of them in the elementary schools, they have used block coding for the lower level VEX equipment. So you could do the block coding, but what it's also got, and if we go up here to files, it's got a new text project. So what we can do is we can start a text project. This is blocks or text. So I'm going to do a text project. And they open up and they give you an example code here of what it looks like. They've got all the type of commands over here. And from what I understand, I'm not a Python programmer. I've never learned Python. I have programmed for many, many years, used all kinds of different programming languages. It's pretty close to C. If you take a look at it here, you scroll down, you've got your if statements, your for statements, while statements. So it's pretty compatible, but what I understand, this is actually Python. And they give you a little example here. If we take a look here, I'm going to highlight this. They've already got this statement in here. What they're doing is they're bringing in the software required to do all these functions that they have over here for these commands. And they're importing that, so that line is necessary. Then down here, they've got the, highlight this, they got the code where you would put your main program inside. So with you put your program inside here, and this area, they give you that as a default. I'm going to move the end of this down a little bit here for main. It's kind of nice. They draw a little line down here to show you how long that area is. All right, so then they've got over here, they got what they call the playground. And this is really cool, this playground they've got. So they've got a little robot on it. Let's take a look at the robot. I'm going to change modes over here. I'm going to change this camera mode right here. And there's their little VEX robot that they've got that moves around the track. I'm going to go back to the top view of it. But here's the track. They've got all kinds of information, the heading, the rotation, the front eye, what it's seeing, the down eye. So it's got a front sensor and it's got a down sensor. It's got location on the graph here. And right now it's at minus 900 millimeters. by 900 minus 900 millimeters in the lower left-hand corner. So the center of this thing is somewhere up here. Let me see how many, what do we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I guess it says it's right there. I don't know, maybe, I don't know how they go about doing that, but anyway, they got the location angle, they got bumpers, they got 2 bumpers on the front of it, and they got a distance sensor on it. And so if we take a look here, I'm going to grab, they got a whole list of maps here. They've got a grid map, and you can go through these and pick them all out. They've got different games with each one of them. The one I'm going to do here is I'm going to work with the wall maze. This particular one right here, the starting point, you can see the robot down here sitting right there. And let me see here. They've got a command in here already. They're just going to say, hey, drive forward for 200 millimeters. So if I wanted to run that command, I'm going to hit, this is the start button, the run button. There's another one up here in the upper right-hand corner, start and stop. But I'm going to run this one. And there my robot moved forward 200 millimeters. And if I want to reset it, I can come down here. I can reset it. It'll stop it and it'll reset it down back to where it starts. You can rerun it again. Get a little idea of what's going on with it there. So they used, let's take a look at the command that they used. They used drivetrain 4. So if we go up here and we click on this, now what you can do is there's a little question mark here. If you click on the question mark, I'm going to move this window out of the way. It has the command there, and it gives you a little layout of the command. It says direction. So the direction can be left or right, and it can have distance on it. It can be forward also. And then it has the units, and the units can be, I think it's in inches in there also. So anyway, it's kind of a neat little tool here to kind of help you get an idea on how to use the command. I grabbed the right one, drivetrain. Oh, turn. No, I grabbed the wrong one. Drivetrain, this guy right here. This is the one I should have grabbed. Let me grab the help for it. So yeah, here's the thing. You got millimeters or inches. You can go forward or reverse, and it has a numeric value in there for how far it wants to go. So anyway, there's our little program. Now, one thing that I did do is I wrote some subroutines, or what they call function calls. And if we scroll all the way down to the bottom here, there's a function name. If I hit the question mark, I got to move our game board out of the way. But here's how they set it up. They define a function. And if there's nothing in the function, they have to have this word pass in there. And they explain that in there. If you want to send some parameters to it, for example, down here, they say print name, and they put the name in there, and they say, brain dot print, and they pass the name to it. So that's a function right there. I'm going to write some functions for this maze. And I've got them written already, and I'm kind of cheating here a little bit. I got a Word document. I'm going to open my Word document up. And I'm going to go down here. I've got one function already written. I'm going to highlight it. Click copy. Now, where I want to paste it is I want to paste it here before the main program, right in this area right here. So I'm going to paste that right there. All right, so there's my little subroutine I put in there. I'm going to move this out of the way. I've got a little comment here. If I call this routine and I put a a value right in there, pass a parameter to it, it'll be the distance right there of how far the robot's going to travel, and it's going to travel in millimeters. I do have a function call right here inside of it. It's called color. And what happens is the robot has a sensor on the bottom of it. Oh, you know what I should do is we should go, let's go up here. I think it's VEX projects. No, that's not where I wanted to go. Come on. Oh, maybe this is it over here. We'll try activities. All right, I'm going to scroll down here. I clicked on that activities. And it's got a lot of, tells you how to use a lot of the capability of this device. And let's see, teacher portal. Back up. Your code. Here's what I wanted to show you. So here's the actual robot that you have. This is the robot that's on the playing field that you're going to be writing code for. And if we scroll down far enough, here we go. So that tells you the diameter of the wheels. It's got electromagnet in it. It's got a down eye sensor. It's got a pen in it. Let's see, get that out of here. It's got a front eye and a distance sensor. It's got a left and right bumper, and it's got a built-in gyro and location sensor. So those are all the tools that are in the robot there. So you can read about it and get some more information about that. I'm going to go back to my coding screen here. And once again, the way I got there was, I think it was this guy, no, this one. I clicked on this, the VR right here. All right, so I have a little function in here called color. Let me go back out. I'm going to bring my color routine in. A little function here. Highlight it. And what this color routine does, copy it here. And paste it there. Space between these two. All right, so the color routine, if my robot moves over a space, what I can do is I can call this color routine, and it can tell me the color. Color could be green, could be blue, could be none, or could be red. And what I did with red is, if I ever get up here to this red checkerboard pattern up here, I say if I find red, hey, that game is over, I'm done. So that's kind of what these two do, okay? So what I'm gonna do is, I'm gonna stick this in here, this command that I have. I'm gonna erase this guy. And I'm gonna try type in there forward. And I'm going to go forward, let's say 100 millimeters. All right. So now what I want to do is I'm going to get my playing field up here. And I'm all set. I'm ready to run. I'm going to run my program. And it moves forward 100 feet. Now, it did call color. I should have had a message printed out over here. I wonder why my message didn't print out. Get rid of my help. And I got my playground. Oh, there we go. I had to go up here. There's a little monitor right up here. If I hit it again, if I hit this little icon up here, it puts a monitor on. Look at that. Print out a message. No color found. So I moved it forward 100 millimeters and it didn't find a color there. So I'm going to add a couple more functions that I've written. So I can go out here to my Word and slide down to the routines that I've written already. And I'm going to add these. Functions in there. I'm going to go back over here. I'm going to reset my playing field. And so I've got some more functions I've added. I have one I call forward stop. And what I like to do is, for example, if I want my robot to move forward, I want it to come up here and I want it to stop. Now, I just happen to know from playing around with this that I'd like it to stop at about 70 millimeters before it hits this wall right here. And so that's why I've got it, I want it to move forward until it hits the distance of 70, the sensor. So as the robot moves forward, the distance sensor is starting to get a value and it's starting to be smaller. If we wanted to look at it right now, let me slide this back over. Right now it's 292 millimeters from this wall right here. That's how far it is. I want it to be 70. And 70, we're going to find out, is going to be about that much from there. So that's how far I want to keep it away. So let's go down here. So that's what my forward program does. It says, hey, if my distance from a wall is greater than 70, then I want to turn my drivetrain on. All right. If not, then I fall into this while statement, while it's greater than 70, because what happens is if I turn my drivetrain on, it's moving forward and the sensor value is changing. So as long as it's greater than 70, I'm going to sit in this little while loop right here. And one of their requirements in a while loop is you got to have a wait 1 millisecond inside a while loop. While loop can't be empty. Once it hits 70 millimeters from that wall, then I do a stop, and then I call the color to see if there's any color there. So let's run this. I'm going to add that to my project here. I'm going to get rid of this example one that I put in. And I'm going to type in there this guy right here, forward stop. And there's no parameters passed. All I know is I want my robot to move forward to the next wall. I got to put in 2 parentheses like that. Now I'm ready to run. This is my main program down here. So let's see what happens. I'm going to turn this on. And there we go. We move forward. And let's take a look. Here it says, oh, it stopped 62 millimeters. So it thinks it's 62 millimeters from the wall. So that's where it stopped at. So next I want to do is this guy's got to turn left. Well, I just happen to have a little subroutine I put together. It's called turn left. So drivetrain, turn, and then you put in here left, parentheses. You give it a value of the number of degrees you want it to turn left, and degrees is what it turns in. So in here, I'm going to put a 90 because I want it to turn 90 degrees to the left. And then this one kind of works funny. If you run this command here for turning it, and you don't wait for it to stop its motion and you send it another command, it'll start running off at an angle and do some crazy things. So I had to put a while statement in here that says, hey, while I'm going to sit in a loop right here while it's moving. Once it stops moving, then I'm okay to continue on. So let's put that command in, and I'm going to hit tab here, jump it over, and I'm going to say turn left, and then in parentheses, I'm going to put 90 for 90 degrees. So I'm going to hit this circle with the arrow here to reset everything. Moves them back, and now I'm going to fire them up. I'm going to watch the robot. Uh-oh, something happened. Project running, have an error. I says, oh, okay. So now what happens is we got to go over here, and we got to take a look at what the problem was. And it says recent call, unexpected indent. Oh, and it gives me a line number 49. So let me go over here to 49. Oh yeah, look at right there. I indented too far. So looks like Python really pays attention to formatting here. So I'm going to delete that space. Get my turn left 90 right where it should be. All right, so let's reset. Yep, robot's back. I'm going to clear out. So I go down the lower right-hand corner, clear out my error messages. And now I'm going to fire it up and run. There it goes. So we went up, we turned. It detected twice that there was no color found. All right, on it. So that's basically how this thing works. Now, what I'm going to do is I'm going to put a few more statements in here. I'm going to go back over here to my Word. And like I said, I had this program kind of put together. So I'm going to go in here. I'm going to copy a bunch of these down. There. Then I'm going to paste those in here to my main program. I better fix the formatting on this guy right here. All right. I'm going to, now you can stop your program. See this prompt programs, so you can stop it like that. But if you want your robot to go back, you got to hit the circle here. So it resets everything. All right. Now we're going to do a bunch of these commands. Remember, these are all functions that I have written up here. So let's run this, see what happens. So one of the last commands I ran was this forward 250. What I needed to do is I needed the robot to end up here. One of the rules of this game is you have to go and touch all the letters or all the spots in blue in order. So you got to write this so it goes to A, then to B, then the robot's got to come up here and go to C, then the robot's got to come down here, go to D, and then to finish up, it's got to get up to the checkerboard. So that's the way this game is set up here. Well, what I had to do here is I had to run from here out to here and stop right here, because when I turn, I want to be able to be right here in the middle. And I had to play around with the number I used down here in this command. Forward just moves the robot forward millimeters. That moved forward 255 millimeters. So that's the forward command, and I had to play around with it to see how far it would go. So all right, I'm going to add some more commands. First, I'm going to reset this. I'm going to go back out to my Word document. And what I want to do is I'm going to copy the rest of the program that I've written. Now, this program doesn't do what the instructions tell you to do. So let me hit copy. I skipped over a few little steps on it. All right, so let's see. Hopefully this thing runs. Oh, I better go look, see if I have a syntax error. Oh, yeah, I might have a syntax error right here. So let me delete that. All right, so we're reset. So let's let this thing run. So it comes out, comes over, goes to A, turns around, goes up. Now it's heading towards B. And then once it hits B, it should head up to C, except I just changed the program so it would just go to the checkerboard pattern here. Left, right, right, left, right. We're watching over here as it's going over the colors. You found the blue ones. It's not finding any color as it's going through here. And now it's heading to the end here. And I suppose you could write the program so it looks at the numbers. You can go after the green numbers too. So it's an option on the program. Here we go. Checkerboard found, game over. So basically, this is the program here. It's, like I said, it's written in Python. If you need help with Python, you can always go out to Google. And I needed help with writing a function. So I said function name and Python and went out and found some resources on the internet. Let me go back up here. I want to go back up here to the VR. Move this down. Go back up here to VR. Maybe I got to close this. Actually, tutorials or activities. Let's take a look at activities. So if I go down to, and like I said, there's a bunch of them here. There's the dynamic wall maze. There's the letter maze. Yeah, let's do the letter maze. So if I go into letter maze, that's the one we just did. It tells you what the challenge is here. Have it move from the start, the green square, to the finished checker square. So that's one level. You could just go from the start to the checkered square. Or you could do the sequence, A, B, C, D, like I started to do. That's a level 2. And a level 3, maybe you go D, C, B, A, and then finish with the robot. So it kind of gives you some different game strategies to use here. And I think it's pretty neat. The programming language works pretty well. The one I was going to do was, let's see, I think it's dynamic. Yeah, dynamic wall maze. This guy right here. Dynamic wall maze. Every time you start the program up, or every time you stop it and start it, it comes up with a different maze. So you have to write a program that can go from the start point to the end point with different mazes. It means it has to find, it's kind of like that Roomba vacuum cleaner, you know, but it's all the different ones. So that's a pretty good challenge to work on that. But anyway, once again, this programming is in Python. I just talked to a teacher today, and I guess that's what they use on the AP computer science classes. They use Python. So your students get a little experience programming Python. If you want to do, this would be interesting. I haven't done this yet. What if I go back? Oh, if I do new blocks project, it'll wipe it out. Okay, here's another thing. It's got open examples in here. So you can open examples and they give you all kinds of examples. You could look at just drivetrains. You could look at using the magnet to pick up objects. You can look at looks, controls. You can see example. They'll give you example programs that you can take a look at and run. Here's one for functions, you know, passing parameters and that. So anyway, I want to thank you. I think this is a great tool. Once again, it's cloud-based. You don't have to load any software onto your computer. So I think I think it'd be a fun tool. So it's virtual. So thank you. And if you get a chance, give me some feedback. Bye.